You are audible and visible properly. That's a good thing. Very good. Thank you. Okay. So look, last day means in our last class, we have completed the exercise number 1.1. Yes, very good afternoon. Now tell me one thing, students. Do you have any problem regarding exercise number 1.1? Do you have any confusion? No problem? Okay. So now let's talk one another theorem, that is called the fundamental theorem of arithmetic. The fundamental theorem of arithmetic. What is the fundamental theorem of arithmetic? Fundamental theorem of arithmetic. Okay, look, fundamental theorem of arithmetic state that any positive integer, any positive integer, any positive integer is either one or a prime number or it can be expressed as a product of primes. The representation is unique except the order of the prime. This is the definition of a fundamental theorem of arithmetic. Whatever the positive integer you will choose, it will be either 1 or it will be prime number or it can be expressed as a product of prime numbers. So the board is somewhat hazy. Yes, write it if you want, write it. Otherwise the definition is also given in your book. Okay, definition is also given in a book. You can copy it from there. It is given on page number 8. Okay, so look, any positive integers is either 1 or it is a prime number, or if it is not 1 and not prime number, then it must be expressed in the form in the product of a few prime numbers. Would you like to give me example of any positive integer? Would you like to give me any positive integer? 6. Okay, one has given 6. Now look, 6 is not 1 and also not a prime number. 6 is not 1, also not a prime number. So 6 must be written in the form as a product of prime numbers. So we know that 6 can be written in the form 2 into 3. Here 2 and 3 both are prime numbers. Okay, so the number 6 can be written in the form of product of prime numbers. Another one has given 8. So 8 means 2 into 2. So as 8 is not prime, not 1, so it must be expressed in the form in the product of a few prime numbers. So 2 into 2 both are prime, means all are prime number. For example, one is given 23. Now look, 23 itself a prime number. 23 itself a prime number. then 12 is given, 12. So 12 means 2 into 2 into 3. So it is also can express in the product of prime numbers. So whatever the number you will choose, it will be either 1 or it will be prime number, otherwise it has to be expressed in the a product of few prime. Got it? Okay. Now what is this? The representation is unique except the order of the prime. For example, we have taken a 6 here. You can write 2 into 3, or any other student can write 6 as 3 into 2. Okay. Means the representation is unique, but the order is not. Means you can write 2 first or you can write 3 first. Okay. So that means order of the representation is not unique, but the representation is unique, order is not. This is the fundamental theorem of arithmetic. I am reading the definition once again. Any positive integer is either 1 or a prime number, or it can be expressed as a product of prime numbers. This is the definition of a fundamental theorem of arithmetic. Now tell me students, do you have any confusion in a fundamental theorem of arithmetic? No sir? Okay, very good. Okay, so do one thing, express 140 as a product of prime factors. This is exercise number 1.2. I am solving the first question of 1. First question of 1. Express 140 as a product of primes. Okay, so look, first express 140 as, okay, so first find the factors of 140. So this is 2 70s are 2 35s are 5 7s are 35. Okay, so we can write 140 as 2 into 5 into 7. 2 into 2 into 5 into 7. Very good. Few student has given the correct answer. But look, I can write this 140 in the form of 2 to the power 2 into 5 into 7, because we know that if I multiply 2 into 2, it will be 2 square. So we can write 140 is equal to 2 square into 5 into 7. Can you write? Tell me one thing. Can you write this? 2 square into 5 into 7? Yes. Okay, so it's expressed. Now write question number 3. 3825. Question number 3. 3825 in the product of primes. So find the factors of 3825. Like this, find the factors. Tell me, this is okay, very good. So it is actually 5 into 5 into 3 into 3 into 17. That can be written in the form 5 square into 3 square into 17. 5 square into 3 square into 17. 5 square into 3 square into 17. Okay, very good. Now students, look one thing. If I leave question number 2, 3, 2, 4 and 5 for you, can you solve it by yourself? If I yes, I know you can solve it. Okay, so now let's go to the next question, question number 2. Now look, in question number 2 we have to find the LCM and HCF between any two numbers by prime factorization method. Now look, we know to find the LCM and HCF by other methods, but here we will learn how to find the LCM and HCF between 2 or 3 numbers by prime factorization method. Okay, so let us consider two numbers. Suppose one number is suppose I am taking 12, okay, and another number is I am taking 16. We want to find the LCM and HCF between these two numbers 12 and 16. So what we have to do? Look, we can directly find the LCM and HCF between two numbers by using division methods or etc. But here we will find the LCM and HCF by prime factorization method. Okay, so write 12 and 16 in a product of few primes. So first split 12 into prime factors. So 2, 4, 2, 6 are 12, 2, 3 are 4. So 12 means 2 square into 3. Okay, and now 16. 16 means 2 8s are, 2 4s are, 2 2s are. Means there are product of 4 2. That means 2 to the power 4. Clear? Now we have to find the HCF. HCF between 12 and 16. Now look at the factors, prime factors of 12 and 16. Now in 12 there are two prime factors, one is 3 and one is 2, and in 16 there is one prime factor, that is equal to 2. Now tell me, what is the common prime factor here? What is the common prime factors? Means the factor having a 12 and a 16 common, so that is equal to 2. So in case of HCF, first write the common factors if any and the minimum exponent or minimum power of the common factors. Now look here, the power of 2 is 2 and here the power of 2 is 4. So we have to take the minimum between these two numbers. So what is the minimum number between 4 and 2? Obviously you will say this, the minimum between 4 and 2 is 2. So it will be 2. So 2 to the power 2, that is equal to 4. That will be the HCF of the number. Now in any case, if there is a no common factor, between two numbers, so in that case the HCF will be equal to 1. For example, if I take two numbers 5 and 7, so you can see that 5 and 7 both are prime numbers. Prime number means the number having no common factor other than 1. So in that case HCF will be 1, and if they have any common factor, so HCF will be the minimum power of the common factor will be the HCF. Okay, and now LCM. Now have you understood the HCF? How to find the HCF between the numbers? Okay, I will give you few more example. Okay, now find the LCM first, then LCM between 12 and 16. So LCM means we'll almost follow the same thing. First we will write the common factors having both the term. So between 12 and 16, 2 is the common factor, so write 2. And in case of LCM, we have to write the maximum power of the common factor. So here the maximum power means the maximum number between 4 and 2, that is equal to 4 into, write all the terms which is not written yet. So this 3 is not written yet, so write 3 here. Okay, so now multiply this, so that is equal to 48. That is equal to 48. Okay, and one more thing, ACF equal to 4, LCM equal to 48. Now what happens if I multiply LCM and ACF? So that is equal to 4 into 48. Now please multiply 4 and 48. Tell me the answer. Multiply 4 and 48 is 192. Okay, and find the product of the number. Product of the number. What are the number here? 16 and 12. Now multiply 16 and 12 once. The result will be again same, 192. Means if you multiply the LCM and ACF, that will be equal to actually the product of the number. So from here we have a formula that LCM into ACF is equal to product of the two numbers. Product of the two numbers. It is true for two numbers only. Okay. So we have a formula that LCM into ACF is equal to product of the number. Product of two numbers. This is a formula. Okay. Now let me give you few question to find the LCM and ACF by using prime factorization method. I am rubbing the board. Okay. Okay. Find the LCM and ACF between the number 26 and 91 using prime factorization method. This is question number 2-1. Find the LCM and ACF between two numbers by using prime factorization method. Okay, so first split 26 by prime factors and tell me the factors. Okay, 26 is equal to 2 into 13, very good, and 91 is 7 into 13, 2 into 13 into 7 into 13. So ACF will be equal to, ACF I told you, ACF means the common factors, the lowest power of the common factors. So here the common factor is 13 and the lowest power of 13 is 1. So that is equal to ACF equal to 13. And LCM, so I told you we have to first write the common factors and the highest power of the common factor, as here the powers are both 1, so that is equal to 13. Into the term we have not written yet. So here 2 is not written and here the 7 is also not written. Okay. So the LCM equal to 13 into 2 into 7. Now just multiply this. Multiply this. And tell me the 13 into 14. $182. Yes, it is 182. Okay. So this is ACF, this is LCM is known, calculated. Now we have to verify whether LCM into ACF is equal to product of the number or not. LCM into ACF is equal to product of the number or not. So find the LCM into ACF. Okay, write the value. LCM equal to 182 and HCF is equal to 13. Now multiply it. Two three six six. 2336. 2336. 2336. I have 2336. Yes, 2336. Okay. And now find the product of the number. Product of the numbers means 26 into 91. That is equal to. The result will be C, the same. Two, three, three, six. That means LCM into HCF is equal to product of the right one line here, that LCM into HCF equal to product of the number, and hence verified. And hence verified. Now, tell me, have you any problems in this question? Any problem? It will be 2366. It will be. Let me see. 6. Yes, 2366. Correct. 2366. It will be 2366. Okay, whatever. This is the procedure. Have you got it? Any problems regarding this type of question? Okay, so if I leave question number 2 and 3 for you, can you do it by yourself, or we'll solve one more question from question number 2? Tell me. If you said I can leave the questions, otherwise we can solve. Will I solve one more question from here? No problem. Can do it. Okay, very good. Now question number 3. Now look, here we learn how to find the LCM and HCF between two numbers. But what happens if we have three numbers here? For example, suppose there are three numbers, 12, 15 and 21. We have to find the LCM and HCF between three numbers by using prime factorization method. So we will do the same thing. So first express 12 as a product of primes. So 12 is equal to 2 6s, 2 3s. So that is equal to 2 into 2 into 3, which is equal to 2 square into 3. Now 15 can be written in the form 3 5s are 15, so 3 into 5. And 21, it is 3 into 7. Okay, so first step is express all the numbers given into prime factors. Next, HCF is equal. Now look, we know that HCF means the highest between the common factors. So we have to find the common factors here. So here look, the common factor is 3 and the lowest power of the common factor is 1. So HCF will be equal to 3. And now the time for LCM. LCM means first we have to write the common factor and its highest power. So here the common factor is 3 and the highest power of 3 is 1 in this expression. Into write all the term we have not written yet. So this term is not written, 2 square, into this 5 is not written, 5, into this 7 is also not written, into 7. Now multiply all the numbers here. Means 420, I think. 420. So 420 is the LCM and HCF is equal to 3. Okay, understood? Yes. Okay, so let's stop it here. Next day we'll start from question number 4. Clear? And please don't leave the group. Let me take your attendance once. Just wait a second.